Thank you a lot for the introduction, and thank you all for staying for the last session. So yeah, I'm Kostas. I'm a principal scientist at Veridise, a startup whose goal is to harden blockchain security by employing formal methods. So today I'm gonna describe briefly our technology and tease some cool things that are coming soon. But first, I want to give you an insight of why we want to apply techniques like verification to ensure blockchain security. And this insight is, surprise, surprise, money. And I'm sure all of you know that bugs in this new decentralized software stack are extremely expensive. And to make matter worse, these bugs can happen in any of these layers of this new developing and evolving stack. For example, so far we have seen detrimental bugs in smart contracts, consensus protocols, zero-knowledge proofs, and the list goes on. So motivated by this, we started Veridise, whose goal is to develop a set of formal method tools in order to ensure blockchain security. And to be a bit more clear, by formal methods, I refer to a set of mathematically rigorous techniques who are able to both discover bugs in code, as well as prove its correctness. And the story of these techniques go way back, but up until recently, they mainly collected dust in academic research themselves. But recently, because of the security critical nature and monetary handling of blockchains, we've seen an urge in the need for providing correctness guarantees of deployed software. To dive in a bit more, when I refer to formal methods, I refer to a very wide range of techniques, from systematic testing to static analysis and formal verification. So, for example, here, techniques on the left side of this figure are more suited for bug finding and usually require little to no user input, whereas like techniques on the other end of the spectrum are more suited for providing correctness guarantees and usually require a bit more human effort to make things work. So that brings me to the main product of our company, which is what we call verification as a service, or VAS, where things work as follows. So the user has to provide the code artifact, and optionally a set of specifications written in our own specification language called V that formally describe the desired behavior of the code. So then our service will run all applicable tools to the input code base, and will report which of the input specifications are verified and which are being violated, and also give concrete bugs for the ones that are being violated. So overall, the goals of our toolchain here are to be user-friendly and also support as many languages and blockchains as possible. So our design evolves around the two following principles. First, we provide a very unified interface to all of our tools using our V specification language. And second, the core logic of each tool is implemented in a language and blockchain agnostic way. This way, we can later on add easier new blockchains and new languages. So before I conclude, I want to give a very brief introduction to V specifications using this very simple specification that describes the desired behavior of a wallet. So in a nutshell, this specification says that if a user calls a method deposit, and this method executes successfully, then at the end, we want the balance of the sender to increase by the desired amount. However, this is a very simplistic example, and V has a lot of more useful and fun features where users, for example, can specify what happens in any possible execution. For example, what happens when a transaction reverts, and also provides ways to describe system invariants and complex behavioral specifications. So Up until now, we have used this toolchain internally to perform several audits, and we managed to find actually quite a few issues, from flash down vulnerabilities in DeFi apps to soundness bugs in zero-knowledge proofs. So moving on, we have more fun things coming your way. First of all, we plan to release a beta version of our VAS service sometime this year. And also, we are planning to release more tools targeting zero-knowledge-based systems, like Picus, a common vulnerability detector for circuits, and Circumcock, which is a tool for proving functional correctness of circuits. And finally, if you want to learn more about these things and you are at DEF CON in October, make sure to attend our CTO's talk, where he will go into more details about our new ZK infrastructure. Thanks so much.
Amazing. Thank you. Is there any question for Kostas before we move on to the next talk?
Does your verification language, does it support temporal logic, or is it just a first order logic?
No, it's a full-on, like, LTL variant that is targeted to blockchain applications. Yeah.
One more question? Yes, no? Or else you can find Kostas after.
Thanks
Thank
so much.
you.